Thank you, Lucy. Welcome everyone to OSMC 2023. I'm glad you're all here, and hopefully I have some good news and good stuff for you to show you. So before we start this talk, yesterday I released Icinga for Windows 1.11.1. It just took 3 months, and it's finally here. And the blog post should be on by today. What is the change and what we did? So basically, what happens is with Icinga for Windows 1.11.1, we broke some stuff. For example, the plain Icinga configuration writer was bugged. The update handling for the entire Icinga for Windows solution was broken. Jaya had some issues. And in some weird cases, the Icinga agent, when you used Icinga for Windows to install the Icinga agent, the system simply rebooted. So never seen that before, but that did happen. So that's also fixed in 1.11.1. So it hopefully never happens again that a production system simply shuts down. It's a great discussion with the customer afterwards. So one thing that we broke with Icinga for Windows 1.11.1 is that the update Icinga functionality is broken. So we fixed that now. It took some time. So all you have to do is add -version release in the back, because the funny thing is, when you didn't specify version, it didn't do nothing. You could add to -version anything you want. For example, like the developer messed it up, and then it would update to the latest version. And if you specified a specific version, it would go to the latest version, not the one you specified. So that is really, really angry, and I'm really sorry. Is log1c the user here? Sadly not, because that was his pull request. He did a fantastic job, and I messed up during the merge. So it was my fault because I bricked his functionality. So I'm really sorry about that. What we also did, what we released last week, is a new plugin collection of the Hyper-V plugins. And we did some various bug fixes with that. For example, the issue was that when you had virtual machines and you deleted the virtual disk from the device, the plugin simply would crash, and now it tells you that the plugin does not or cannot find the virtual disk assigned to a virtual machine. That for some reason can happen in environments, and also a small freeze could happen because on how we check the Hyper-V functionality is being installed on a system or not. That's something we also fixed. For the cluster plugins, the same functionality is still built in, and we will provide a new version for that once we figure out how we can properly and reliable check if a cluster is installed on any Windows version from 2012 or back to 2022, because that's quite a mess. What's also new, you can now check for duplicate virtual machines. So in case you have virtual machines with the identical name, you have now a plugin that will tell you if there is an issue there, if there is something that shouldn't happen. If you, for example, for some reason, Hyper-V lets you create virtual machines with the same name, on the same hypervisor even, so this plugin will now tell you if you have something like that, because that could cause other issues. You can also check for blackout times now, so like Hyper-V, VMware vMotion, Hyper-V has the functionality to distribute the virtual machines on a different node, and you have a blackout time metric that will tell you how long it took for the virtual machine to migrate to another hypervisor, and that's not also something you can check and validate if it's working properly. And last but not least, you can also check how many Hyper-V nodes should be in your cluster, how many are actually in the cluster, to see if you lost one during a transaction. Now, a first thing, summarizing Icinga for Windows. Who of you has never heard of Icinga for Windows before? Okay, that's great. Who's using Icinga for Windows actively? Okay, that's for you. And let's change your mind a little maybe. So, let's give a brief overview first what Icinga for Windows is. It's a PowerShell framework, so everything is related on PowerShell. That's why Age of PowerShell, the talk. And with Icinga for Windows, we provide a basic framework that allows you to write your own custom plugins and visualize every single plugin in the same way. So for example, for the Windows updates, we fetch all the Windows updates from the machine and also split them in certain categories, like Windows Defender category. We have, for example, general security updates, roll-up updates. So you can specify if you're only interested in Defender updates, you can add a threshold to your simple plugins and tell, okay, if a Windows Defender update is pending, then send a notification because there are updates missing. Then for Hyper-V, for example, what I mentioned before, that previously crashed, you now get a notification in that case that at the location for the virtual machine, it couldn't find the snapshot. So that's now working properly, and as you can see, we can pull a lot of metrics out of Hyper-V. You shouldn't, by the way, you shouldn't use the both all for your database. Your database admins will love it. And last but not least, we have the CPU plugin, and here is one thing that I wanted to talk about because it caused quite some confusions regarding Icinga for Windows 1.11.1. Or 1.11 general, because what happens with the plugins, with the new version is that your cores could exceed 100% CPU usage, which is not a bug, which is intended. Because the reason for that is that we receive complaints that our metrics we fetch here from the system are not identical to the one provided by the Windows Task Manager. So we changed that, but the Task Manager kept all the performance data by 100%. And that changed with Windows 8. Now, the reason for that, why it can exceed 100%, just to clarify that, is because of Intel Turbo Boost and AMD Precision Boost Overdrive. So because when you have a CPU, for example, with 3 GHz base clock and 4 GHz boost clock, then the difference between this is if the CPU is utilized 100%, it makes a difference if it runs on the base clock or if it runs on the Turbo Boost clock. So that's why you have a difference here. The task manager simply caps that at 100%, and we decided not to do that because it gives a much more detailed overview on what is going on with your CPU cores and your sockets you have. Sorry? Exactly, yeah. So now the metrics are identical to a task manager, but we just don't cap it at 100%. I just want to clarify that because it caused a lot of confusion at a lot of discussions back then. So just for you to know. And what is also great with the PowerShell handling is that we can actually provide a basic framework for you to develop your own plugins and your own tools. We have some basic things available. We have Windows Basic plugins, so CPU, disk, memory, services, and so on, but also for MS SQL, for Hyper-V, and some cluster checks, and of course, Active Directory and Exchange will hopefully come next year finally, so we can complete the Microsoft stack in that case. So for the basic architecture for you, who have no idea how the basic architecture of Icinga for Windows is structured? Okay, a few. So let's get you there. So we have our Icinga master, for example, and we have our Windows machine, and we somehow need to deploy our PowerShell framework to that. What we can then do with the framework is to actually manage our Icinga installation. So whoever installed an Icinga agent, you require something like endpoints, you require zones, your ticket for certificate generation, and everything related. And the Icinga for Windows PowerShell framework will all deal with that for you. So then you can fetch the configuration from the Icinga director and also add this information to the agent as well. The agent will write everything into the event log. Then Icinga will tell the agent to execute a check. The Icinga agent will call the PowerShell. It will load the PowerShell framework, and then we execute the plugin, and everything we do is logged to the event log. Now, how does this look like? If you install the Icinga for Windows PowerShell framework, you have a simple command called Icinga. If you run that, you will run into the Icinga management console, and this is something you can use to create your deployment configuration for each Icinga for Windows installation you have. So for example, if I go to 0 base installations, a text-based interface, I can say I want a new configuration. And for example, because I have the possibility here, I can use the Icinga Director Self-Service API. The benefit with that is that when I set a certain agent template to be deployed in a certain zone, for example, in Berlin, New York, whatsoever, the configuration is then sent from the Icinga Director to Icinga for Windows and allows an easier deployment. Now, when I press 3, I have to provide the Icinga Director URL, and I can do that. I simply copy it down here. And After that, it asks me for a self-service API key. And the self-service API key, I can directly fetch from my host template. So if I click on host on the director, host templates, I have created a generic agent template. And here you can see the full Icinga for Windows installation template already pre-rendered by the Icinga director. So in general, what you can do, you simply copy-paste. What's the question? It's just for backwards compatibility, because on older Windows machines, the problem is that they don't allow that. And that's the reason why it's still there for backwards compatibility. But yeah, you should use newer versions. So you can simply copy this entire script, deploy it on your machine. It will connect to the director and will all do by itself. Now what you can also do, you can simply copy your API key, paste it into the IMC, and then it will load all the basic data it has configured for the Icinga director. When we press A for advanced, we get a lot more detail what's happening. So, for example, on how the host name is configured, if the firewall, for example, is opened or not, because in this case, the agent will connect to the master. We also contribute or tell which agent version is installed. That, for example, I want to install the plugins in that case. So I can hit 13 and say I want to install the plugins. Right now, I don't want to use to install the Icinga service, not a JA profile, and I also don't want to install the RP-checks feature. So I can configure everything like that. As long as I do not register this host inside Icinga director, that means that this is a basic template that every single new Windows machine can run. If I click enter, I have now the opportunity to print the installation command or export an answer file. And if I do that, I now have my installation command with all the configurations I created. And all I have to do in that case, if I have a basic configuration, I simply need to replace the self-service API key, and then I can distribute my Windows machines on different hosts and different zones, different network areas, or different locations. Now, I've already prepared something. And if I go now to my Windows machine, I can simply paste this entire command, and then it will start to run the installation of Icinga for Windows. Hopefully. Please. Okay. I love live demos. So what now happens, it will now use packages Icinga.com as a repository for all components, for the Icinga agent, for the framework, and for the plugins we want to install. And what happens now is that we have the basic setup I showed in the architecture guide. So now it will install everything, it will create the certificates, it will do all the handshakes with the Icinga certificate authority, so that basically the Icinga system is back on running, and that's great. Now, here's the certificate generation part, where everything runs through. And the biggest problem is that I can show when the installation is done, is that this architecture requires a lot of resources on the machine, because every time Icinga will start a PowerShell and then it will call a plugin. So what we ended up with was a cool invention that's called the Icinga PowerShell service. And that's a simple C# binary that allows you to run a PowerShell command as a background daemon behind the scenes. And this allows us to provide a REST API feature. So we have a REST API you can connect to. By default, it's located on the local host. And what you can do with that is you can execute your checks, and they only get deployed by the PowerShell. They will do an invoke web request to the REST API, schedule the check there, and transform the metrics. And the reason for that is to improve the performance. So installation is done. And just to give you an overview on what I mean, if we now go to, that's the wrong host. I need the Oracle server. Go to services, and for example, let's get the load check because that's quite interesting. So, if I click on check now, it will hopefully schedule the check. Might take a while. Yeah, here it is. And the execution time is about 6 seconds for this plugin. That's now with the PowerShell calling everything, doing all the checks, doing everything related. And the thing is, if I go now with the classic Icinga, I'm very impatient. So for example, if you do like this, check now, check now, check now, check now, then something interesting happens because every time you press on check now, it will start a PowerShell and execute a check, which means that the performance of your system will look like this. So you shouldn't do that. Now, the thing is, what you can do is we can use now, as we installed Icinga for Windows on this machine, we can run the IMC and do some basic configurations. Of course, you can all do by commands and automate it as well. But what we can do is, for example, we go to the component manager, we go on install, and then we can install the Icinga for Windows service binary. Please. I hope the internet is not breaking. If the internet breaks, my demo is done. So we have now here service, so I can press 1, then it tells me, do you want to install the service? Yes, I want to install the service. And then it will do everything related to that. So it will configure this, the user, it will configure the service, it grants the permissions, and ensures that it is running. It takes a while. Time might run out. There's a big chance that I'm either too short or too long. Let's see. Come on. Okay, so now the service is installed. And what I can do in addition, I go to settings and click Icinga for Windows features. By the way, if you go L, you can list the commands, and then you can see what the system is calling. In that case, it's wrong. That's great. But now I can install the RP-check forwarder feature. So what it does now, it will register the background daemon. That's a simple commandlet. It will enable everything that I can run the checks over the REST API. And now when I go back to my service, you see, by the way, that's great. So if I click check now, then hopefully the check execution is much faster. Maybe. 6.9, okay. Let's try again. I love live demos. I should have prepared these numbers and just fake them and say, yeah, it's all great. Okay, 6.7 seconds. Now, the thing is, when you, for example, now simply click check now all the time, then all your checks should be queued over the REST API. And as you can see, the load is much more healthy. It's still not great, but it's a much bigger improvement, because what happens now is that the PowerShell will start, it will load a framework, and then it will schedule the check over the REST API. It's handled there, and the result is transmitted back, which means all the library loading for performance counters, everything related, is simply done in memory and not installed every single time. But as you Yay! So let's see if we can improve that. Yeah, the PowerShell service, it's a simple C# binary. If you don't want to install the service, you can also run a scheduled task with that. It's also fine, because there are many ways in Windows that you can choose certain things. Now, what happens with the architecture is that, as we can see, it didn't really improve something. So what we came up with, which was a colleague of mine, is that we replace the PowerShell and use the PowerShell connector. And basically what that is an easy way to improve the performance. So you can find that one on GitHub. And what it does is that when you, so if I download the release, and you have a simple Go binary, you navigate to Program Files, Icinga to SBIN, and place the binary right there. What it does, it will take the entire PowerShell command that Icinga for Windows is generating, passes it to the Go binary, and based on that, it will then generate a curl for the configuration. So if I go to Icinga director now and commands, the easiest way to do that, look for the PowerShell base plugin. And instead of calling the PowerShell, we write PowerShell. By the way, there's a reason why I tell you all of this, so stay with me. So PowerShell connector, I click on deploy. And when I click on the load check on inspect, I see that right now it's calling the PowerShell with all this code back here for the check execution. Now once Icinga is back online, I can do now a check now. And with some luck, Icinga is already there. Maybe. No. I'm very impatient. Come on. Please. Oh, come on. Reload the core. The thing is, I don't think it's scheduled. It's scheduled right now. That's the issue. I don't think the agent is back online. Let's see. PowerShell connector. Okay, there's a call with the PowerShell connector. That's great. No, that's false. Here, task manager. Icinga service. Okay. Please. Yeah. And now, check execution is 1 second. That was the big moment. And the funny thing now is that if I keep clicking on check now, what simply happens is that the PowerShell connector will get started. That doesn't consume much of resources. And if you look in the performance, it looks much better now. Because what happens now is that only the actual check that is running will generate a slight peak of load, but the Icinga for Windows API will limit concurrent connections to 5. So even if you DDoS your entire configuration, if I do something crazy, that no one really does, to select every single check here and click on check now, then what happens is you see there's a small spike now, but it's all the checks that are simply executed, and it goes quickly back down. And I don't have any PowerShell connector service back online because it's already finished. And that's great. Now the thing is, of course, what we intended to, what I did, I think 2 years ago, is that this is fine, but it requires to deploy another binary, you would need to change configuration and everything related, and it's quite a mess. So what we finally came up with, and the Icinga team and I had a great time doing that, is that we simply replace the entire PowerShell, and the Icinga agent will directly call the REST API. So there's no more binary being called, no more forking, it's just the Icinga agent will call the REST API. Now, for this to work, you require the Icinga masters to be on 2.14 or later. You require the Icinga agent 2.14 on the systems. You require Icinga for Windows 1.11 and the Icinga director 1.11 in case you use the Icinga director. Now, the reason for that is that Icinga 2.14 has a built-in check command. And to get this installed, you have to do the following. If you have updated your masters and use the director, you go to your infrastructure tab on the Icinga director, on the Kickstart wizard, and then run the importer again. This will import the Icinga for Windows API check command. And this check command you can then use to go to your PowerShell base plugin. So just to give you a short idea on what's going on. That's great, that doesn't work. Second. Where is it? If I go to any service right now that's being executed, you see at the moment, if I go and inspect, that receives a curl error. That's great. Let's try again. And now it works. So here right now it calls the PowerShell connector. Now what I can do now with Icinga 2.14 is I go on the PowerShell base, and then I simply import a new check command, which is Icinga for Windows API, store that, and deploy the configuration. Now this template will override the check command that is being used by this check command and will internally build the entire request to use a curl-like statement. Now the thing is, if you don't have the time to upgrade your entire infrastructure to 2.14, you can do a hybrid setup with 2.13, for example. There is, however, one important thing you need to keep in mind, that either if you use Icinga Director or use it manually, there is a check command that you need to apply to your system. I think Alex tested it back to Icinga 2.6. So this should work even with Icinga 2.6. And this is a check command object that you need to deploy in your global templates. So either Icinga for Windows or the Icinga Director will do it in the Director globals by itself. If you have a global Windows zone and no Director global, you need to deploy that to your Windows machines, to every machine that uses Icinga for Windows. Otherwise, your Icinga agents will crash during config generation. So that's important. So that's why it's recommended to update everything to 2.14. But you can do a hybrid approach as well. Now, if I go back to my check, if I now go on the firewall and click on check now, no idea why I get these error messages down there. So if I click now on inspect, then we will see that it now changed to a curl, and now the check is directly executed by the Icinga agent. It will connect to the Icinga for Windows API and execute the check there. So now there's not even a PowerShell connector process spawning, it's just inside the Icinga agent doing all the work and doing everything related. And that's great, because if we go back to the load check, click on check now, then we should get instant, okay, 2.7 seconds, okay. But still, the lower the number is, the better, of course, because you have less performance locking, but that's basically it. Now, basically that's 2.14, that's a feature. And there's one more thing I wanted to add in this talk because it's quite interesting. So, for example, Windows Updates is always having the issue that you can't fetch certain updates because you have a permission error. Now, you can, of course, always run your certain user, network user, whatsoever, and extend the permissions. But what we encourage everyone is to use Jaya. Who knows about Jaya? Who have never heard it before? Oh my God. Okay. So, Jaya stands for just enough administration. And you can think of that similar to a sudo list on a Linux system. So what you can do is you can create a Jaya profile and allow a user to only run certain commands. So for example, you can whitelist a user to only use, for example, restart service Icinga 2, but no other service. So that's something you can grant permissions for. The issue with Jaya profiles is basically on an Icinga for Windows scale with hundreds of commandlets, it's quite a pain in the ass to actually generate the configuration because it's a lot of dependencies, a lot of system dependencies and everything related. And what we created is the Jaya installer. So the Jaya installer will take all your Icinga for Windows components being installed. That's the wrong one. And what you can do is you can also generate a user with that. So, for example, if I go to for Jaya, I can now use install Jaya profile with managed user Icinga. So what happens is that the Icinga for Windows will now generate a user Icinga on the local machine. It will generate a random password. The user is designed to not be able to log on locally. He doesn't accept WinRM commands. He doesn't accept remote desktop connections. And this user is simply created to run as a service on this machine. And then a Jaya profile is generated for this user with all the Icinga for Windows components installed, all the background daemons, all the plugins. So it gives the, so it does everything for you. It also prints a warning, for example. So if you have plugins that use certain code, for example, not sure if you know PowerShell enough, you can write C# code and generate on the fly DLL libraries to inject in your code whatsoever. That's great. But it's also something you should be aware of. So Icinga for Windows will tell you if such code is being used to give you an idea, okay, is there something weird going on? For the disk attributes, for example, and the UNC pass plugin require that. But you should always verify your plugins. Now when a JR profile is built, it compiles the JR profile catalog. And once the catalog is configured, it will install the JR profile, restart the Icinga for Windows service, and then you have elevated privileges on the machine with this specific user in the restriction that the module or the profile is giving you. Yeah, I really need to remove the sleeps from the installation. So now we are done. And if I now go back to the to this Windows update check, might take a while, but when I reschedule it now, then okay, IP is not ready. That can happen. Yeah, it takes a while. So we come back to that later because I run out of time a little. But I can show you afterwards. So now the easiest way is to run always JR because it gets rid of the requirement to always change your permissions, to find out what kind of WMI permissions do I need, what kind of system, what kind of folder permissions. So it's very easy to use. And even if you create your own plugins that fetch certain information, you can simply generate the JR profile automatically and do your checks. Now, that's basically what we have today. Who wants to see the future of Icinga for Windows? Yeah, you had no chance anyway to say no, so you're trapped with me here. So, we have been working quite a lot on certain things, and I want to show you something, and hopefully it works. So, this flag is just for me to extend a demo. And what we did is that we try to resolve certain pain points we have with Icinga for Windows. So for example, this is the 2.0 preview, and we have, that's just a basic overview right now, and what you have here is a system health overview now that also tells if the service is degraded. We can get a system health overview and see what's actually going on. We have 3 parts right now to check if the services are running and if the REST API is connected. So you get a basic information in the management console locally in your system if everything is working properly. Now, what's cool about right now is that we have a new thing called automation. And the part is that I've worked with Tom a little, and now we can use the Icinga director and my user credentials to log into the Icinga director. I have to type in my password, and what I can then do is log in. With this, I can use the Icinga management console to connect to the Icinga director and do some fancy stuff. For example, I can do deployment. I have created an OSMC Windows test environment, which you can later on configure directly in the Icinga director. And what's happened is you can generate filters based on host names, custom variables, everything related. And we now see we have 2 machines here, Oracle DB and SalesNet MS SQL. Now let me select a template. Just as we did before, we generated in the Icinga for Windows Management Console, we generated some installation pattern. With Icinga for Windows 2, you can name these templates and use them globally on your environment. So now I use the master zone, and for the full demonstration, uninstall where? What? I will simply uninstall Icinga for Windows right now from this Oracle DB machine. And what you can do with Icinga for Windows 2.0 is to use Webinare, PowerShell remote execution, in case you can use it, and deploy your configuration on every single host that you can connect to from your local machine. So basically what happens is that your local machine will play relay to the target Windows machines. So for example, when you have a Windows machine that cannot connect to the Icinga director, that's the most common case. You have DMZ, whatsoever, you can't connect to the Icinga director. So what you can do now is you can use your machine. Maybe you can connect to this machine over Webinare. And what happens is that your machine will fetch the information from server 1, forward them to the Icinga director, get the configuration for this machine, and then starts the deployment on this machine there. So the server no longer requires to actually communicate with the director. So, and if everything works now, I press 3, then hopefully something starts. Okay, it starts deploying. And if we go on the machine now, I prepare the folders. Hopefully this works. Modules. Okay, we have the framework is already installed now. And now it deploys Icinga for Windows with the template I chose. So it installs the framework, it installs the REST API feature, the agent, configures everything. And hopefully this works. And maybe it doesn't. Yeah, I made a mistake. So, yeah, no. That's the wrong button. Because I made a mistake. Because what happens is if you use the Icinga director with a self-service API, the host will receive a unique template ID, so you have to drop the self-service key, like that. And now it's going to work. So I can test this afterwards. I can start the deployment again. Right now, the input is blocked until the deployment is finished. This, in the final version, this will be in the background task. It will be presented up here, so you can still use the management console to start different deployments in addition. So I'll run the Oracle check later on. Now the thing is, why do we do that? Why do we build an automated installation directly inside Icinga for Windows? Now, the thing is that we want to make it as easy as possible because many of our customers neither use Puppet or Ansible or SCCM or anything related. And maybe they can use Webinare. I know it's a security thing for most companies, but some do and use it. And we not only want to make sure that you can automatically deploy your infrastructure, but also do inventory management with that. So that means that you can connect to your Windows machines, fetch inventory data like is there MS SQL installed, is there Hyper-V installed, get the data back, import them into Icinga director to then increase your monitoring metrics. I planned this talk for 30 minutes, by the way. So that's one step. The other thing is that what we want to do with Icinga for Windows 2 is a smart deployment. So for example, if you're not sure if you have Hyper-V installed or MS SQL installed on your machine, it will automatically install these plugins once it detects a certain feature. So it's way easier then because you don't have to know actually what's running there. You get it back with the inventory data and the log output afterwards. Now the biggest thing, of course, is with Icinga for Windows that we want to make it as modular as possible. So if you don't want to use Webinare or can't use it with the tools, we want to make everything abstract as possible so you can integrate it in Ansible, in Puppet, in every tool you want, so that all the core functionality to write the configuration, to deploy everything is as easy as possible and as integratable. Now, for the roadmap. Basically, what we want to do with Icinga for Windows 2 is to rewrite most of the core features. I have some slides from last year as well, because the thing is that some things are not as performance improved as we want to, and also way too complicated. However, what we want to maintain is full backwards compatibility. That means you simply use update minus Icinga, you update to version 2, and everything is still working. That's a big goal for us. We don't want migration phases to change certain things or modify everything. If you simply use Icinga for Windows stuff provided by Icinga team, it simply works, is backwards compatible. If you write own code, we also want to maintain that you simply can use your old features, your old functions, and simply can upgrade later on and modify them if required. We want a full working deployment and inventory management, the smart installation handling, and also proper cluster monitoring. Now for cluster monitoring, that's a big pain point because Icinga basically doesn't know anything about clusters. It executes a check, you get a result. And for example, if you have MS SQL active and standby, one of them might give you an error because the database is not working there, but actually it is working because MS SQL is running. Now, what we want to do is that we want to use Icinga for Windows to relay these information. So basically what we want to achieve is that when a plugin asks one MS SQL host, by using Icinga for Windows API, you fetch all the information from your cluster network for this particular service, combine all the metrics, do some analysis if it's working properly, and if so, then the states will be okay. And for example, if the MS SQL one active crashes, reports are critical, all other services will simply report a warning that the service is degraded to get a better overview of that. Yeah, I have to skip a little. That's the slides from last year because they are still the same. We want to rework most things. Most important part, there won't be a 1.12. So who follows GitHub? Today should have been 1.12. It's not. But we have plans for 1.12 and 2.0. The first beta will launch in June 2024. So that's the release schedule for version 2. And we want a second beta in RC1 at OSMC 2024 because we want to make sure that everything works, the backwards compatibility is working, and want as much user feedback as possible to get things running and working. And we will only include the tested features, everything else will be experimental. So if the cluster feature is not ready because it's broken, because it doesn't work at all on different custom environments, we might also ditch it. But we will want to make sure that everything is included. And about 1.12, it's not entirely a gone because we will, of course, include bug fix releases. We want to improve the certificate handling and JR overall over Webinare, which is right now not possible, and also improve the service as is and prepare 2.0 later on. So it's much easier for the upgrade. And I'm finally done. Holy crap.
Christian, thank you.
And as you, no, it's wrong. Here it is. Yeah. Okay. Are there any questions?
Any questions here? I have a question actually. You said Icinga for Windows 2 will have a long beta phase. How can we help to test?
Yeah, so basically what we're looking for is, if you reach out to us, is that we want to make sure that we have a big variety of different user environments to ensure that all the plugins are working, the automation is actually working in case you can use Webinare, for example, but also if you use Ansible to deploy your tools, just as an example, that we know if it's working properly, if there's some modification to be done, because we want this release to be as widely tested as possible because we do a bunch of changes to it. So simply reach out to us at info@icinga.com, for example, or info@netways.de, and we would appreciate test environments so we can test the new code on. That would be great.
All right. Are there any questions?
Everyone is eager to go to lunch.
Okay. Then thank you again, Christian. Very good.
Thank you.